Okay, so we're going to have a look at something slightly different to arithmetic sequences. Okay, so geometric. So the difference between them isn't constant. Okay, so it's not the same each time, but if you notice what's actually happening each time, each one of these is being multiplied by 3. Okay, so each one of these, what's happening? It's halving. So that's what a geometric series is. You have a common ratio, so you're multiplying by something each time. Okay, so for example, if this is my geometric sequence, you have A, the first term, okay, and then you have OR, which is your common ratio. What are you multiplying by? So to get the second term, I multiply by OR. To get the third term, I multiply by OR again. So OR squared, OR cubed, etc. Okay, so can you see what's happening with the OR? When T3, it's OR squared. T4, it's OR cubed. If I want Tn, what do you think it would be? A OR
to the power of 4.
Now, that would be for T5, it would be OR to the power of 4. Exactly. T6, OR to the power of 5. T7, OR to the power of 6. N, Tn would be OR to the power of, what's happening to the
minus 1.
Minus 1. Lovely. Okay. So each one of your powers is 1 less than the term number. So if you're looking for the third term, it's 3 take 1. Fourth term, 4 take 1. Nth term, n take 1. So this is really important. Okay. Your Tn is A OR to the power of n minus 1. That's your general term. Okay. So these are really important. Now, how do you get OR? So to get OR, how would I get it? Let's go back up to this sequence of numbers. How do you think you'd get OR? Like, okay, I know it's multiplied by 3, so OR is 3. But what would I do with these to figure out what OR is?
Divide.
Yeah, divide what?
T2 by T1.
Lovely, exactly. T2 divided by T1, or any T3 divided by T2, as long as you're doing that term divided by the one previous to it. Okay, so that's how you get your OR. And that is literally it for geometric sequences. So let's do a few questions. Let me just have a look at your log tables. So we're here on the same page, page 22. You have your general term for geometric, okay? So that is on page 22 of your log tables. Okay, so let's do a few examples.
Miss, how do you know that T2 is A OR?
Because what's happening each time is I'm multiplying the first term by something. So what did I have to multiply 2 by to get 6? 3. And what did I have to multiply 6 by to get 18? 3.
Okay.
So in this case,
3,
yeah, I multiply it by whatever the ratio is. So I multiply it by OR. Then the next time I multiply it by OR again. Okay?
Okay, thank you.
So, example 1. So find Tn and T10 of the geometric sequence. So I know Tn is that formula, and I know to get my OR I need to do T2 divided by T1. Okay, so over here I'm going to write out my first term, which is 1, and my common ratio, which is the second divided by the first. Okay, so that's just a quarter. If you were to do the third divided by the second, I would do it like this in my calculator. Okay, it can get a bit confusing if you have to do that into the calculator. So if I was putting this in the calculator, what I'd do is I'd press the fraction button first. Then I'd say 1 over 16, 1 over 4. Okay, so that's a quarter. If you start doing 1 over 16 over 1 over 4, you get a completely different answer. Okay, so just be very clear. I think this is probably safest. 1 over 16 divided by 1 over 4. And you get 1 over 4. Okay, so there's your common ratio. So we're looking for Tn. And we know it's a or to the power of n minus 1. So a by or to the power of n minus 1. Now, I have a fraction and a power. What do I do? Can you remember your indices when you have a fraction being raised to a power? Where does the power go? Yeah, thank you. So that's 1 to the power of n minus 1 and 4 to the power of n minus 1. Now, what is 1 to the power of anything?
0.
Careful, that's anything to the power of 0 is 1. 1 to the power of anything is always 1. Okay, so it doesn't matter, as long as you have a 1 to the power, it's just 1. So this is my Tn. Okay, you might remember from your indices, you could write this. I have a 4 and the power on the bottom. What happens when I want it to come up to the top? What happens to the power? Yeah, it becomes a minus power. So I'd be changing the minus n and minus minus 1. So you could write it like that, or you can leave it like that. It's totally up to you. Okay? Now, the question is find T10. So if I want T10, all I'm doing is putting in 10. Okay? Instead of my n. Now, throw it into your calculator, and that's what you get. If it won't go into the calculator with the 1 over, just put 4 to the power 9 into the calculator and get that answer out and throw it on the bottom. Are you?
Miss?
Yeah.
You know there in the second line where it says 1 n minus 1 over 4 n minus 1, how did you get rid of the n minus 1 on the top one?
1 to the power of anything is always 1. Always, always.
Okay, yeah. Okay.
So it doesn't matter what n is. 1 to the power of 10, it's still 1. Okay? Because you're just multiplying it by 1, however many times, which is still just 1. So always, if you've 1 to the power of anything, you'll just get rid of the power, it'll just be 1.
Okay, thank you.
Okay. So, we do another one. Can I get rid of the board?
Yeah.
Okay, thank you. So in a geometric sequence, T3 is 32 and T6 is 4. Find A and R and hence write down the first 6 terms. Okay, so we know it's geometric and the third term is 32. So Tn is A or to the n minus 1. T3 is A or to the 3 minus 1, which is A or squared. And I know T3 is 32. So A or squared is 32. I'm just going to do it like that. A or squared is 32. That's the first thing we have. Let's do the same for T6, which is A or 6 minus 1. So A or to the power of 5 is 4. Now, I have these two, and I've got two variables. It is going to be some form of simultaneous equations, but it's not going to be like the usual x plus y equals a number, okay? We've got two things being multiplied here. So what you're going to do is you're going to get one variable on its own and you're going to substitute it. Do you remember that? Kind of. So in this one, I'm going to get a on its own. Okay, where would that r squared go? Yeah, underneath. Okay, it's at the top of this side, it goes to the bottom of the other. So A is 32 over r squared. So now, here, instead of A, I have 32 over r squared by r to the power of 5 is 4. What can I do?
Substitute, but never mind, I don't know.
We need to figure out what r is first. So it's 32 r to the power of 5 over r squared. What do I do when my bases are the same and I'm dividing powers? What do I do with the powers?
Common denominator?
No, I don't need a common denominator. Go on.
Minus 7?
Yeah, lovely. This is 32 r to the power of 5 over r squared. Okay, now r to the power of 5 over r squared, you take away the powers, so 5 take 2 is r cubed. Okay, so we did that in algebra 3. Now to get the r cubed on its own, that 32 will come underneath 4 over 32. I'm just going to come back here. So r cubed is 1 over 8. If r cubed is 1 over 8, how do I get r? If r squared was 1 over 8, how would I get r?
You just get the square root, so then you get the square root cubed.
The cubed root, exactly. Cubed root, good, of 1 over 8. Okay, and you can throw that into your calculator, or the cubed root of 1, which is 1, over the cubed root of 8, which is 2. So r is a half. And now that you know r is a half, you can go back up to one of these and fill it back in. Okay, so I'm going to fill it back into this one because I already have a on its own and I'm looking for a now. So just go back here. A is 32 over r squared. A is 32 over a half squared. Okay, and again in my calculator I'd probably say 32 divided by bracket a half bracket squared. Okay, 32 over, so then I get 128. Okay, so I found my a, I found my r. So a is 128 and then r is a half, so I'm multiplying by a half each time. So multiply that by a half, 64. Multiply that by a half, 32. That by a half, 16. How many do I want? The first 6 terms. 1, 2, 3, 4, 5. And by a half, 6. Okay, so there's my sequence of numbers. You start with your first term, which is 128, and then get your common ratio, which is a half. Half it, half, 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 half. Is that okay?
So did you just fill in the a and the or to Tn equals a or n minus 1?
Oh, you could have done that, but no, I actually just started with 128 because it's my first term, and I know my common ratio is a half, so I'm just multiplying by a half each time.
Oh.
That's all I did rather than filling it in, but you totally could fill it in if you wanted, yeah. So you'd have a 128, a half to the power of 1, to the power 2, to the power 3, to the power 4, etc. I think it's probably just quicker to do half at each time though. Okay. Now, just a note, can I get rid of the board? Okay, now when asked for 3 consecutive terms, use A over or, A and A or. If we think about our geometric series, we start at A and then we multiply by or and then we multiply by or again. But if we were to go one before that, okay, I'd be dividing by or. So for 3 consecutive terms, just learn that these are the 3 that you use. Okay, don't use these 3 because what's going to happen is nothing's going to cancel and your life's going to be much harder. You're going to use these 3. Okay, so it's just something we're going to learn off. If they say something about 3 consecutive terms, we're going to use these 3. Okay, so I'll show you what I mean now with that. What does product mean?
Like when they're multiplied.
Lovely, thank you. Okay. The product of the first 3 terms of a geometric sequence is 216 and their sum is 21. Given that or is less than 1, find the first 3 terms of the sequence. Okay, so this is the scenario where we'd use these 3 as our first 3 terms, okay? So they're telling me the product of them is 216. So that's A over or by A or is 216. Okay, so what's going to happen is A by A is A cubed or over or is 216. I'm just multiplying the top line, multiplying the bottom line. And your or's cancel. So that's why we use these 3. because it allows us to cancel the ours. So if a cubed is 216, a is the cubed root of 216, which is 6. So straight away I can find out what a is. So just learn that. Now, the next part of the question, it says their sum is 21. Okay, so the sum of these, a over or plus a or is 21. Now, I already know that a is 6, so just throw that in. Pull him over. 6 over or plus 6 or 6 take 21 is minus 15 equals 0. Notice anything about that?
Quadratic.
Lovely. It is, yeah, it's a quadratic. Okay. To get rid of that or on the bottom, I'm going to multiply everything by or. And I'm going to get 6 plus 6 or squared minus 15 or equals 0. Okay, so I have this quadratic. I'm going to factorize or minus b, and I'm going to get 2 answers. Now, the question said or is less than 1, so it's not that. So or is a half, okay? So I had a is 6 and or is a half, and in my sequence of numbers, it was a over or, then a or. So the first 3 terms are 6 over a half, then a half, and then 6 by a half. So that's a over or and then a in there. Sorry, girls. Yeah, so an a there and a 6 there. So that's 12, then 6, then 3. So they asked me for the first 3 terms of my sequence. So a over or, a, and then a or. Okay, so it's just a much easier way if they're talking about the product of 3 consecutive terms to use these 3 rather than any other 3. Now, I just want to do one more example, if that's okay. Is this example 4?
Yeah.
Thank you. Can I get rid of the board? Okay. So 3x and x plus 6 are the first 3 terms. Okay, so find the value of x is the first one. Now, they're the first 3 terms of a geometric sequence. Okay? Now, back when it was arithmetic, how used we find what x was? If this was arithmetic, what would we do to find x? What do you know about arithmetic?
The differences are the same.
Exactly, so you'd get the difference between those 2 and put it equal to the difference between those 2. Now, it's very similar with geometric, okay? It's not that the first difference is constant, but there is a common ratio. So your ratio is the same. So what that means is your ratio of these two is the same as the ratio of these two. So T2 divided by T1 is the same as T3 divided by T2. That divided by that is the same as that divided by that. Okay, your ratio is the same. So all you're going to do is fill that in. So x over 3 equals x plus 6 over x. What would you do then?
Cross multiply.
Thank you, lovely. So that x comes up, x squared, and that 3 comes up, 3 by x, 3 by 6. Again, you have a quadratic. So you get x is 6 and x is minus 3 when you do factorising, or minus b. Now in the question it says they are the first three terms of a positive, okay, sequence. So a geometric sequence of positive terms. That means I shouldn't be going backwards here. Okay, so positive terms means 1 or higher. If x is minus 3, okay, that's not a positive term, so it can't be minus 3. So that means x is 6. Okay, so my sequence is 3, 6, 6 plus 6, 12, and so on. Okay, part 2 of that is find the 10th term of the sequence. So to find the 10th term, you're doing a or to the power of 10 minus 1, which is a or to the power of 9. A is your first term, which is 3, and or is your common difference. So what are you multiplying this by each time?
2.
Yeah, okay. If you're not sure how to get or, you do T2 divided by T1, 6 divided by 3, which is 2. So what we end up with is 3 by 2 to the power of 9. 1, 5, 3, 6. That's the 10th term. Okay,